two teams of 9 members each engage in a tug of war. Each of the first team's members has an average mass of 65 kilograms and exerts an average of 1,411 Newton horizontally. Each of the second team's members has an average mass of 72 kilograms and exerts an average force of 1,429 Newton horizontally. What is the acceleration of the two teams and what is the tension in the section of the rope of the two teams? This question is based on the Newton's laws. Okay, here are the two teams. Each team consists of 9 members. Okay, so what happens here? The team members, each one will pull the rope in two different directions. Okay, here are the team 9 members in this team and 9 members in this team. So I will call this as the first team, this as the second team, and then the mass of the first team, average mass of each member in the first team is 65 kilograms, and then there are 9 members, therefore total mass is 585 kilograms. Similarly, the average force is 1,411 newtons. So if I multiply with 9, it will be 12,699 newtons. Okay, for this one. So the total force F total is equal to this one. Okay, 12,699. And next, what happens here? You go to the second team. When you go to the second team, there are also 9 members. The team consists of 9 members and they are pulling the rope in the opposite direction. Okay, this is the point, and then these people are pulling the rope in this direction, these people are pulling the rope in this direction. This is the tug of war. Okay, and now what is the total number of people are same. This both the teams consist of 9 members, so the total mass is equal to 648 because the average mass of each person in the second team is 72 kilograms. We have to multiply with 9, we will get this one. And then for the second team, the average force is 1,429 newtons. So if we multiply with 9, we will get this value. Okay, 12,861. So what is the net force? Because there is a difference in forces. Second team is pulling with a force of 12,861, and then the team 1 is pulling with a force of 12,699. So there is a difference in some force. Therefore, net force is acting along the rope in the second team direction, because the second team is pulling in this direction now. So therefore, the net force is towards the second team. So when the force is towards the second team, there must be some acceleration. Whenever there is a net force, it obviously produces some acceleration according to Newton's second law. So what must be the acceleration? To find the acceleration, so this is the net force divided by total mass. Total mass means we have to consider the total mass of the 18 members. Okay, so the total mass of these 18 members is 585 plus 645 is equal to 1233 kilograms. Therefore, acceleration is equal to 162 newtons divided by 1233 kilograms is equal to 0.13 meters per second square. This is the acceleration. Now, to find the tension in the rope, so this acceleration is acting towards the second team, because the second team, the net force is towards the second team. F net is equal to, I write here, F net is acting in this direction. So when the F net is acting in this direction, so acceleration is also in this direction, the second team direction. Okay, the acceleration is along the second team direction. Now what we have to do, we have to find out the tension in the rope. To find the tension in the rope, we know F is equal to MA. So let us take this first team. You can take either first team or second team. Just like that, I took the first team. I will explain the second. If you take the second team also, what happens? Okay. So sigma F is equal to M1A. So sigma F is the net. We have to calculate the net force. Net force is equal to 9F1. This force, because I am taking the first team. Okay. So F1 into 9 minus F tension is equal to minus M1A. because acceleration is in this direction. For these people, it is the negative direction. Am I right? These people are pulling them. Here are the two teams. This is the first one, and this is the second one. Okay, and the people are pulling in this one. So the force is in this direction, and then acceleration is in this direction, and then tension is also in this direction. These people are pulling in this direction, and then tension is in this direction. Tension is acting in this direction. Am I right? When people are pulling in this direction, tension will be in this direction. And moreover, acceleration is also in this direction. Okay, now why I am writing all this is because the direction and the sign is important. Okay, acceleration is in this direction means negative. For these people, the acceleration will be negative because the force is in this direction, acceleration is in this direction. So F1 into 9 minus F tension is equal to minus M1A. Therefore, F tension is equal to M1A plus F1 into 9. See this one, we have to take this one. So reshuffle the equation. Okay, then you will get this one. Now you put the values 585, M1 is equal to 585 times acceleration. Acceleration is equal to 0.13 plus F1 into 9. So that gives the value of 1.27 into 10 to the power of 4. Suppose if you want to take the second team, okay, you want to, whether it is the first team or the second team, the value should be the same. No, you should get the same tension in the rope because the tension is same along the rope. So it should be the same. I will explain if you take the second team, what happens. So let us do this one. Sigma F is equal to MA. Okay, so I will show you M1, here M2, A. I am taking M2A. So what is happening here? The force F2 into 9, okay, minus F tension is equal to M2A. Agree? Now F tension is equal to F2 into 9 minus M2A. And then you substitute the values and then check, you will get the same answer. Okay, because why I am saying this is because the tension is same in the rope. You can solve the equation for the tension either taking this equation or taking this equation. Okay, both will give the same answer. Understood? This is mainly based on the Newton's laws. Okay, same amount of tension is acting in the rope, and then the acceleration is also same. Only thing is the direction of the acceleration is different. So for the second, because the net force is along the second towards the second team, so the acceleration is along towards the second team. Therefore, for the first team, we have to take the negative sign. Okay, if you take that one, you will get the answer. Hope this helps. Thank you. Bye bye.